Hello everyone, welcome to the channel Statistica Hub. So today we're gonna learn about what does data have, what can we do with the data, some basic understanding like how do we summarize the data. So let's take this picture. Okay, this is a simple picture so that we can see what does this picture trying to say. So it states that people say what does people say? People say I am just an average golfer, but I will show them I am really mean. So technically, okay, this is someone golfer as a player. So he states that people call him average golfer, and he is trying to show them that he is really a mean. Okay, so mean. So he stated two different things. First thing is average, and the another one is mean. So in this particular video, we'll try to see what does the average mean to say and what does this mean trying to say, and is there any combination or any relationship in between these two terms. Okay, now we know we have taken up some data. We can have some data at every point of time, you are watching this particular video on YouTube. So if I go for only YouTube, on every second we can see millions of new video coming out on the YouTube. Okay, great. So the data for every video, like how many minute video is that one, how many watch hours, how many views, how many likes, everything, how many comments. So those analytics are summing up to be some data. Okay. So we have a lot of data. That means we have a pile up of data, and we don't know what to do with this particular data. There's so much of data. We have no idea what to do. So initially, if I go for any data, I can't find any pattern or any trend in the data. Okay, like if I go for any data and if I see the data, I can't state anything like, okay, it has some positive trend, some negative trend, or some pattern kind of thing. So for understanding the basic idea regarding what the data contains, we go for some measuring of central tendency. Okay, as the name suggests, central tendency. Okay, so we have central tendency. So as the name suggests, central tendency. So how the data is tending towards the central value. This is the basic meaning, or can say the middle way. Okay, so this is the meaning what is the middle value or the central value for our particular data. Okay, so that means to say we have some data. If every dot is denoting some data point, okay, we have a lot of data and we need to find some central value. Okay, I go for the middle value from this side, so I can state, okay, the middle value or the central value can be something over here. Okay, so if I say this is the central value, okay, now what does this central value mean to say? This central value mean to say, or with this can be taken to be some average. Okay, this average is known as central tendency, where this average is like, I can say this average is most representative value of our data. Okay, for the data, I can state this is the central value. Okay, so this can be the most representative value for data. For example, if I go for I have a class of 100 students. Okay, I am teaching you some course from MTH, and if my dean, okay, the college dean or the school dean, that guy came up to me and say, okay, tell me how's the students performing. So in that case, I have a data for every student out of this 100. Okay, this data 1, data 2, data 3, and so on, data handle. But to the dean, I will state some average value so that he can take, okay, if I say the average score out of 100, if the maximum marks are out of 100, then if I say, okay, the students are attaining roughly a marks of 70. Okay, so to the dean, I will give this particular number that is some average value. So this average value states that from the complete data, this can be summarized or can have a central value of 70. So 70 basically represents the data. Okay, this is the initial understanding. What does our central value, central tendency mean to say. Okay. So in statistics or mathematics, we go for initially, we have particular kind of statistics. We have statistics in study. So for central tendency, we have initially, we study for like what is mean. Then we go for the median value. And after median, we can go for mode. So these are the major three statistics that we study for our initial goal of measuring central tendency. Okay, so that's what the like basic understanding of what does central tendency mean to say. Okay, now let's take up some example. This states that hey, welcome to my health club. Okay, so I'm running some health club, and okay, so technically we have some particular kind of classes. Okay, we go for some swimming classes. Okay, we go for some judo classes. Okay, we go for some martial arts. Okay, and we go for some like pre-workout or heavy workout. Okay, so in my particular health club, we offer these kind of particular classes. Okay, so a person come up to me and he states, okay, can you tell me like which of these classes is suitable for me? Okay, so technically, if I am the boss of this health club, and this person came up to me and I claim that I can offer you a class according to your age. Okay, so the factor that is defining our classes is age. Okay, so what will I try to do? I have like classes for like if I say this is class A, this is class B, this is class C, and this is class D. Okay, so we have class A, we have class B, we have class C, and we have class D. And if a new person came up, okay, this is the new person. And okay, he came up to me and I'm the owner of this health club. And if I state, okay, I will define you, or I can give you some particular class as per your needs or as per your age, I can give you particular class. Okay. And that person came up to me, then I can have four options. Okay. Then what will I try to do? As the factor is age, I will try to see the inbuilt data that I already have for the ongoing classes. Okay. Like for the age group A, so sorry, for the class A, we have some average age of like 18. Okay. For the class B, the average age is like 27. Okay. For class C, we have some average age of something like 25. Okay. We have D, something like 20. Okay. This data is like quite dispersed. I can state this to be like swimming can be stated as 28. This can be like 47. Okay. This is dummy data. This is 35. Okay. If this is the particular data that I have, and suppose that a person came up to me, this N is the new person that came up to me, and he states, okay, my age is roughly 27. So can you tell me like which classes I must join? So this is the basic understanding, like how do we use the average or the central tendency values. So I have the averages to be like 28, 47, 35, 20. From seeing the value like, okay, 27 is the age of this particular person, the new entry. So I will tend to give him class A. Okay, so you are suitable for class A because all the people in this class A having an average age of 28 and your particular age that is 27 is very close to 28. Okay, so you will fit fine in this particular class. Okay, so this is the thing or the meaning like how do we use our central tendency. Okay, and this common measure of we have some common measure of average is mean. Okay, that mean to say we have various kind of averages. Out of these various kind of averages, we have a particular type of average that is known as mean. Okay, and you know like how do we calculate mean? So if I go for like how do we calculate mean? So that means add up the number divided by total number of number. Okay, so if I have data something like 1, 2, 3, I will do like 1 plus 2 plus 3 and total number of data is 1, 2, 3. Okay, divided by 3. So that will give us a mean value. Okay, so this was initial understanding of how do we use this general tendency value. Okay, now let's come up to something different that I just stated. This is some common measure of average. Okay, so if I say, let's take up this particular example initially. So if I have the current attendance of pre-workout, or can say power workout, the age group for the different people that are attending our class power workout, that is 20, 21, 20, 19, and 20. Then these are the data that I have. Then how do we work out the average age of the power workout class? So we know the average can be mean, and mean equal to, we have like 20 plus 20 plus 21 plus 20 plus 19 divided by 5. Okay, this is an example of how do we calculate mean for the basic understanding of mean. Great. Now let's come to this point. I stated one thing, that we have some particular kind of average, like some particular kind of average. This is mean. So like if I say my mean is average, is there any error in this particular format? If I say my mean is exactly equal to average, give it a thought. Like what's the wrong with just calling it the average? It's just that I'm used to, okay, we are always using like average equal to mean, that is nearly same as mean equal to average. But is there any error in this particular format of defining mean equal to average? Let's go and see like what does this mean to say. Okay, so I hope you have guessed something regarding the same thing. So let's take an example. Okay, so assume that I'm going to have some craving regarding ice cream. Okay, like I am going to have some ice cream. So I go to some ice cream vendor. Okay, and I state him, okay, can you please give me some ice cream? Can you give me some ice cream? So what does this vendor will do? He will ask me like, okay, I will give you the ice cream, but at least tell me which flavor or which ice cream do you want? Like which flavor ice cream? Initial question that will be there. Okay, so that mean to say we have ice creams for different flavors, say some vanilla, some strawberry, some butterscotch, or any kind of ice cream. Out of these ice creams, he will ask me to define like which particular ice cream do you want. They all are called ice cream, but I am supposed to find some particular kind of ice cream. That means to say that I need to provide him some more information so that he can choose out of them. Okay, so this was the initial example, some dummy example. In a similar format, we have various kind of averages. So out of these averages, each average is defined in some particular or different format. Then we need to provide some particular information. If I say my average equal to 30, and if I have to equate this thing to the mean, in that condition, I need to provide some additional information. Like every average is calculated in some different format. That's why we can't use mean and average as nearly same. Like in average, this is a worst class. This is like these are all the averages. Out of these averages, some quantities out of here, these are mean. Okay, so basically this is a bigger set average. Out of that set, we have some subset that is mean. Okay, so every mean is an average, but every average is not a mean. Note this point. Okay, I hope you got the basic understanding regarding this thing. Okay, now let's come up to like there is something defined as letters and numbers. So in mathematics or statistics, we have always seen like we have some quantities. Okay, we have the data to be like in the initial stage, we have some example of age group, na? That is like 20, 21, 20, 20, and 19. Great. So let's take up the example again. So 20, 20, 20, 19, and 21. That was the particular data. Okay. So this is a specific data. Okay, I have taken up some class. Out of that class, I have data points as something like this: 20, 20, 20, 19, and 21. Sorry. Okay, so we have particular or can say specific data for a particular class. And if I need to generalize this thing, Okay, if I need to generalize this format, in that case, I will define these specific A's that are number data to some letter data, say x1, x2, x3, x4, and x5. Okay, so this is the beginning, like how do we use letters and numbers? So for the numeric data that we have, that is some specific data, and we need to calculate the formulas or our observations for some standard or can say some general format. In the general format, we need to define this in a general format, and as per that generalization, we will define some letter terms to our each numeric value. Okay, so technically it is something like labeling the data. Okay, the initial understanding regarding the same is like letters and number mean to say we will define or we will label the each the data point as per some letter. Okay, now the point is like in this particular data we have like one observation, two observation, three observations, four and five. We have total five data points. Okay, now what if we don't know how many numbers? Like in the general scenario, like in this specific data, we have used some letter terms for our numeric data. But in this particular data, we know the data points are five. But what if in the general format, we need to define for some general case? So what if we don't have know how many data points do we have? In that particular case, what we will try to do, we will say, we will say that the number of data or the number we have data, number of data points to be n. Okay, like for the general case, we can state it to be like this. Okay, we assume that the data are n. In that case, we know the average for in this particular format in the previous example, we know the average is sum divided by 5. So that was something like 100 divided by 5, that is equal to 20. Okay, in this particular case, the same format will define, and in this case, the sum will be coming out to be x1 plus x2 dot dot dot, that means to say some running format plus xn. So technically the mean will be x1 plus x2 plus so on xn divided by n. Okay, so this is the general format for finding our mean value. Okay, now let's come up to something different. Okay, so we have defined something like over here, that is summation term. So that sum is coming out to be like x1 plus x2 plus dot 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 xn. So this is some different kind of format. In mathematics, we have something defined as summation. So this summation mean to say this is some shorthand form for writing sum term. So if I state this summation in this format like x1 plus x2 plus xn, this is summation x. So it is all adds up on like this is summation x and this is x1 plus x2 plus dot 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 xn. So this is a bigger term and this is a shorthand term that is adding up all the terms. If I say xi, that is I running from 1 to n if we have n data points. So this is a longhand form, this is a shorthand form, like this is some basic mathematics stuff. Okay, now let's take up something like this. So in general format, we defined that summation x1 plus x2 plus so on xn divided by n, that is coming out to be mean. So in this particular shorthand form, this can be written as summation x divided by n, where summation x means to say add all the numbers together, then divide the however many they are. Okay, so we define the mean to be, this is basically our mean value. So mean equal to summation xi divided by n. Okay, now symbolic form of the mean. So in mathematics or statistics, we don't usually use these terms like mean, median, mode, or something like that. We define that in some symbolic form. So we have defined as mu. So mu equal to summation xi divided by n, where I running from 1 to n. So technically this mu, this is known as mean. Okay, so again the same thing. I am mean. Some people say I'm average, but deep down I am mean. Okay, like this is the set of averages, and out of these averages, some are mean. So this is stating that some people say that I am average, but deep down I am mean. I hope you got the mathematics or understanding behind this thing. Like every mean is average, but not every average is mean. Okay, now there is some example, this particular example. Okay, So how do we go for calculating mean age for power workout class? Here are their ages. Okay. So we have age as 19 with frequency 1. Okay. So one person is having an average age of 19. Okay. We have age 20 for three people. So 1, 2, and 3. This is 20, this is 20, this is 20. And we have a one person which is 21. So we need to find the mean. So that will be equal to summation of these terms, that is 19, 20, 20 plus 20 plus 21 divided by 5, that is coming out to be 100 divided by 5, that equal to 20. Okay, so this is how do we calculate our mean. Now in this particular format, we have seen like this 19 is getting repeated one time, this 20 is repeated three times, 21 is repeated one time. So in different format, we can define something like this. If our x data is something over here, and we have frequency over here, so I have x1, f1, x2, f2, and so on, xn, fn, like frequency for each term, each x value. So we define another column stating fx, that is multiplication of frequency to its number or the data point, that is x1 f1, x2 f2, and so on, coming out to be xn fn. Then we go for our mean, that equal to mean equal to x1 f1 plus x2 f2 plus so on, xn fn, divided by f1 plus f2 plus so on, fn. In another format, I can write this to be like summation I running from 1 to n xi fi divided by summation fi, like I running from 1 to n. Okay, so for the frequency table, we can define our mean something like this. So that is also a formula that we need to memorize. Okay, now let's come up to like you understand what is mean, like how this mean is different from average, or like what is the difference between average and the mean value. Now let's come up to this thing like back to my health club. Okay, great. So I'm running the health club, and someday I got a man, okay, a man in his late 50s who wants an exercise class composed of other middle-aged folk. Okay, so everyone who is coming out in my, like this is my club. So we have like 15 to 25. Then we have like 25 to 30 age group, or can say 35. We have 35 to 45. We have 45 to 60. Okay, we have these kind of age groups. And we have some class, particular class A for this age group. We have class B for this particular age group, C for this one, and D for this one. Okay, so let's assume that this guy came to my club and he say, okay, can you assign me some particular class so that I can have class or some exercises with the people middle age. Okay, as he is from his mid 50s. Okay, so technically he is something over here in this particular data. He is falling in this particular data. Okay, now I have these kind of classes, but initially if I don't have any information regarding this, and if I say we have class 1, we have class 2, and we have class 3, and the mean age, or you can say the average age for these particular classes is coming out to be like this is 17, and this is 25, and this is 38. Okay, and I state that this class is like some pre-workout, and this particular class is something like swimming, and this class has some kung fu. Okay, some kung fu classes are running over here. Okay, so if this person came up to me like his age is like mid 50s, late 50s. Okay, so that is something like 57 or 58. If I take up the age of this person to be this thing, then the initial understanding states that we will go for that class whose average is nearly or closest to this particular value. So we have 57 and 38. We have 57 and 25. We have 57 and 17. So technically we can see that this difference is much smaller than other two. So we will add up this person, Clive, to our class C. Okay, so Clive has added up to the class C. Okay, great. So now, after a while, the class C was for the Kung Fu people. Okay, they were practicing Kung Fu. So this is something that Clive experienced. Okay, so we have Kung Fu people in the class. The students were like this thing. Okay, this is a young guy. This is another a young guy. This is someone known as the coach. Okay, I can see from the picture. This is some coach, and this another student. Okay, so we can see he's young person. She is young person. He's an old man. So basically, he's the master. Okay, and this was the new person that I added him in this particular class. Okay, so he states that I ended up in the Kung Fu classes with lots of young men and a few ancient masters. My back will never be the same again. So this is something that was not supposed to happen. Okay, initially we claimed that as per your age, we will define you or we will assign you to some particular class such that the particular exercises in a class are meant to be for your age group people. Okay, but this person end up in some kung fu class that is not a good option for a old age person. Like someone with an age of 57, if I say okay, go for some kung fu classes, then he's like, I'm not that active. Okay, so technically, due to some error in our average, this man ended up in the Kung Fu classes that has caused some disturbance to him, like he is having some back pain or any kind of problem. Okay, so I can see that if I have the four data points over here, four data points, and out of these particular four data points, three are young data points, like okay, less than 25, if I state them to be like this thing, and one person is the master. So one person having a data, roughly, if I say he is nearly 100 years old. Okay, so this is like something error has been occurred in our calculation of finding the mean. Okay, so let's come up and take what does this mean to say. Okay, so we have to make some histogram. Okay, these were like mean of summation xi divided by n. This was the calculation part. Now we will go for some making some histogram. So histogram is basically some making some histogram or some visualization for the data. If I go for this particular data, the power workout classes, so we have frequency over here and we have age group over here. Okay, so for this, if I say, okay, I'm coming to this 19 only. Initially, this is 19, this is 20, and this is like 21. Okay, 19, 20, and 21. And if I say this is like our 1, this is our 3. So this will be coming out to be something like this. Okay, so this is the histogram. From this histogram, we can easily see the like the central value can be something like 20. Okay, this is the central value that is 20. Okay, now let's take up the example of Kung Fu classes. For this particular kind of data, we have the histogram something like this. If we have the frequency over here, if I state like 613, okay. So if I say this is like 1, then this will be something like 3, and technically this will be something like 6. Okay, initially the data is coming out from 19. So again, the same thing. If I say this is like 19, okay, this is 20, this is 21, and we have some two data points like these are can be for the masters. Okay, so this will be something over here. Okay, 145 and 147. Okay, so if I go for age group 19, that means we have frequency of 3. Okay, for the age group 20, we have frequency of 6. Okay, for 21, again the age group is 4, frequency is 3, and there is no data in between these part, and we have a frequency of 1 over here and 1 over here. Okay, so like what is the difference between this data and this data, or can say this plot and this plot? So technically all the values, like majority of values are in between this data, like from 19 to 21, but some values are that are far away from the particular values that the data is supposed to be in. The majority of data is in between 19 and 21, but some values are far away from this particular point. Okay, in that case, we can see that some average central value can be from this data, some central value can be from this data, and we have two central values. And the central value for these two values, this can be something over here. Okay, so the central value for this complete data, okay, for this complete data, the central value is coming out to be something that is away from the majority of data. Okay, so technically in the case of Clive, we have calculated the mean or the average from this data, and in this case we know the majority of data or the age group in the class group that was something like 90 to 21, but the average was coming out to be like 38, but there was no student with the age group of 38. All the students are in between that part. So technically this is an error that arises Now understanding why does this error arise or what made this error to happen. Okay, so this is the histogram again. So this was the age for Kung Fu people or the Kung Fu students. This is the frequency, and we can see like okay, the mean is coming out to be like 38. Okay, for this point, this is like 38. This is the mean coming out to be. So the age, we have something defined as outlier. Okay, so if I have a data point something over here, this is my data. Okay, majority of data is around this circle. Okay, and if some data is far away from this circle, okay, this data point, something that is bigger than this data or something that is very smaller than this data, so these extreme values are known as outlier. So technically what is the meaning for the definition of extreme value, or can say the outlier? So outlier are the extreme value from the data. Okay, if I state some data to be like 1, 2, 3, 2.5, 3.5, 1.5, and so on. And in between, if I inbuild something data to be 150. In that case, all the data is something over here like 1, 2, 3, but this data 150 is far away. So this is some extreme value. Okay, so this is the basic meaning of an outlier. So technically, outlier is a point that is extreme value, or can say this outlier is a value that is not close to our majority of data. Okay, so that tend to change our average value to some extent. Now let's see how does this value change or how does this value act in our particular data. So if I take up something like this, okay, I have two extreme values in this particular case. Sorry. Okay, I have two values in this extreme case. This one is like 145 to 146. The another one is 147 to 148. Okay, so if I take up this slot over here, so that means to say our first central tendency will be something over here, that is to be like 20, and the another central tendency something over here that can be stated as 146. Okay, if I take up that to be central tendency. So if I erase this part, in that case, my central tendency for this value, only this value, this will be 144, 145. Okay, 145. This is happening only when I am just neglecting the value that is like 147 to 148. In that case, if my central tendency first was this one and the second one was this one, our majority or the average central tendency will be something over here. Okay, if I add up this column or this data point, that is 147 to 148, and I don't reject this one, in that case my central tendency will be something like this. In that case, this is first, this is third, the average central tendency will be tending something rightward, so that will be something here. Okay, if I say this is including and this is something excluding. So what is the observation? The observation states that as the number of outliers or the outliers increase, there is a shift in our average, or can say the mean. Okay, so there is a shift in the average that is due to this presence of outlier. So when outliers pull the data to left or right, I can see when we count only one outlier, in that case the data is shifted something towards right. If I calculate both the outliers or include both the outliers, in that case is it shifted further outward, or that is further towards the right. That means we have some skewed data. So what is the meaning of skewed data? So when outliers pull the data to the left or to the right, in that case, we have the data as skewed data. Okay, so the data can be skewed. Like we have something like this. In this particular data, the histogram was something like this. Okay, we have two outliers that are tending the mean towards this point. So technically, this is skewness. In another format, we can have something like this. Okay, we know the majority of data is over here, so mean will be here. And if I say some values are there, so they will tend the mean to be something towards this point. So technically there is a skewness. So the skewness or the data can be skewed towards its left or towards the right. Okay, so that data is skewed data, and skewness happens due to the presence of outliers. Okay, now take up what is skewness. So skewness mean to say, is there any symmetry? Okay, if this is the symmetric data, that is all that data is like this one. There is no skewness, nothing, any tail is forming. In that case, the data is symmetric, but sometimes the data can be like this. This is known as positively skewed data, or the another name for the positively skewed data is right skewed data. Okay, that means to say there is some majority of data points in this region, but there are some outliers in the right tail that is making the mean towards the rightward shift. That is right skewed data. In a simpler format, or in a similar format, we have defined to be something known as left, or can say negatively skewed data. Okay, for the negatively skewed data, the another name is left skewed data. And what does that mean to say? That mean to say the majority of values in the data or on the right side, but there are few outliers on the left portion of the data that are making the mean to be shifted towards the left. Okay, so this is the meaning of skewness and outlier. Okay, so for calculating any kind of average, that is mean, we need to deal with outliers. Okay, if we don't deal with outliers, in that case, the same thing that Clive experienced can happen for many cases. Okay, like he was a guy who was supposed to be in some class that was as per his needs, but he ended up in some class that was not supposed to be a good option for him. So that happened because of the presence of outlier in the data. So while calculating the central tendency, or while dealing anything in the field of statistics or mathematics, we need to find like how the outliers are present in the data and how they can be dealt. Okay, so this was all about mean. I hope you got the first portion of central tendency, like what is central tendency and what is the meaning of mean and what is the meaning of average. So this was all about lecture 1, that was regarding central tendency part mean. Thank you.